This is about circumference of a circle for high school geometry course. I'm starting here with my bowl. See my poor bowl? My bowl is lonely. I have to draw around my bowl because the mug that I have from that dam, Hoover Dam, is locked in my classroom. So I get to draw around this bowl, and it's not a bowl from any place special, so it doesn't get any special adjectives. It's just a bowl. So that's how I make my circles. Let's talk a little bit about circumference. Well, what is circumference, you might ask? I heard you ask that, Dominic. I heard it. Here we go. Circumference is the distance around a circle. Yay! Okay, that was tough. Make sure you make a note of it. I bet you didn't already know that. This one you may not have thought of in quite these terms. Pi is the ratio of the diameter to the circumference of a circle. That's the definition of it. That's where it comes from. And I think we've mentioned before that this comes from a long time before recorded history. At least some of our earliest histories that are recorded have already recorded it, so it makes it kind of look like they already knew it. The relationship between the diameter of the circle and the circumference. There are various places back in the Babylonians. It's in the Hebrew scriptures with regard to outfitting their temple. It's just all over the place. People had figured it out a long time ago that the distance around a circle is approximately 3 times, and a little bit more, what it is across it. And that's true for all circles. It's not technically an aspect ratio, but it tells us a lot of the things that the aspect ratio tells us. Remember when we did aspect ratios of rectangles, what we learned is that if they had the same aspect ratio, that means that they were the same shape and that they were similar. For example, why a little bitty TV, the picture looks the same as it does on a big TV when they're the same aspect ratio. That was particularly true, you'll recall, of the old TVs, which were all the same. Now we've got a new one, and they're pretty much the same. So the aspect ratio there of the rectangles, you'll recall, told us that it was the same shape, so that however large or small you made it, you wouldn't stretch or squish down any of the characters on the TV. Well, aspect ratio is a ratio of the dimensions, and that's kind of what the circle, what pi is. And what we find out is that it's always the same, no matter what you do. So if I take the aspect ratio of my little blue bowl here, and I take the aspect ratio of my little coaster here, they're both circles. Guess what? All the way around this little blue bowl and across this blue bowl, and divide is about 3.14 all the way around this white circle, and with this little hieroglyph in it, and then all the way across it, and divide is about 3.14. What does that say about these two? Okay, wait for it. This is going to blow your mind. You're going to blow your mind. Dylan. I bet Dylan knows. Yeah, Dylan knows what it means. It means they are both, wait for it, round. Okay, who would have thought that? That all circles are round. Wouldn't you know it? All circles are round. That's what pi tells us. I know you've been working with pi for lots of years, and it's lots of fun, but did you ever know it was really quite that profound? That pi means that all circles are round. Okay. So when we're messing with circles, we're frequently going to want to have an exact answer. In terms of pi, you've heard me say that before. When it needs to be an exact answer, you need to leave pi in your final answer, and it'll be part of the answer, like 3 pi or 7 pi or something like that. Be sure you check on the terms of the answer, what your specifications are supposed to be, so that you'll know how to do it. Okay, now here's a big whopping theorem. Ooh, this one's hard. Woo, you've never heard this. Here we go. the circumference of the circle is pi d, or 2 pi r. Okay, well, this is a theorem, so we really should prove it. Okay, well, here, let's work on it. Here's going to be my proof. Okay, so I'll start like this, my statements, my reasons. Here's number 1. Well, pi equals the circumference divided by the diameter. Well, how do I know that? Oh, yeah, it's the definition of pi. Okay. 2. Therefore, pi d equals circumference. Why is that? That's the multiplication property. That was tough. Okay. Wouldn't you like to have more proofs like that? Okay. Next, definitions. We'll talk a little bit about some of the measurements on a circle. Here we go. The arc length is a portion of the circumference of a circle. We've talked about that before. And let me remind you what we've talked about before, and that the length is not the same as the measure. Here in this circle, the red arc and the rest, the length of this. For the length of it, you would just kind of, if you didn't really know what it was, what should we do? I'm grabbing a ruler. What should we do is grab a ruler and work it around it. Say, oh, well, let's see, I'll do it in centimeters. That's easier. And you kind of go around like this, you kind of estimate it. If you had a tape measure, it'd be easier. Yeah, you're not going to get real accurate anyway, but I'm just making the notion that it is a linear measure that's wrapped around. That's the arc length, like using a tape measure, something that's flexible. Okay, so the arc length is a distance. It's measured in linear units, like centimeters or inches, how long it would be. Okay, if I'd start here, and you got to keep it tangent all the time, or you're not going to even come close to it. It's about 2 7/8 inches. I did it in inches. Again, remember back from our previous unit that the arc measure is the same as the measure of the central angle, and that's measured in degrees. So just make sure you're remembering what you've already heard, that the arc length is not the same as the arc measure. Okay, well, let's look how we can do it. I mean, you know, a little bit better than just walking the ruler around it. That's not the coolest thing right there. Okay, I'm looking here at this handy-dandy circle drawn with my circle bowl drawer that I don't have any cute adjectives to describe. Okay? I'm looking at this. The 60 degrees here is the central angle. I know that the entire around the center, if I'm going to measure, is going to be 360. A whole circle is 360. So, I take it then that this angle, right here, this central angle, is 60 degrees out of 360, or 1/6 of the total. Does everybody see that? But since the circle arcs measure is the same, now not the length, the measure, since we call this a 60-degree arc and a 360-degree circle, notice the relationship there. They're the same. 1/6, the arc is 1/6 of the total circumference, and the angle is 1/6 of the total central angle. Okay? Well, we're going to play with that along with the definition of circumference, which was that really hard theorem we just proved, you know, pi d or 2 by r. We're going to play with that and see what we can do. And what we're going to find out is that since it is proportionate, how would we do that? Okay, so let's say, well, the measure of the arc is 60 degrees, and the measure of the whole circle is 360, which again will reduce to 1/6. And we know that that's going to be proportionate to the actual length is going to be in the same ratio. It's the same part of it. It's a sixth of the measure, and it's a sixth of the length, right? Okay? So let's see how that works. So I need to know, okay, well, when I'm talking about the length, what am I talking about? I'm talking about the part, which is going to be the measure of the arc, and I'm talking about, no, I'm sorry, the length of the arc. What did I say? The length of the arc, and then the whole thing will be the circumference. Do you see that? It's going to be the same. The measure of the arc itself is 1/6 of the whole circle, and the length of the arc should be 1/6 of the whole length. Yeah, that's kind of a duh, isn't it? So to be able to do that, we need to know what the circumference is, because this is the one we're trying to find. Okay, well, circumference, I recall, is 2 pi r. So that'll be, and we have radius is 10, so that's going to be 2 times pi times 10, or it's going to be approximately 62.8. So I'll put that in here. I'll have 60 is to 160, as 60 is to 360, as what we need to know, the length of the arc, is to the circumference. I hope you see that. In each case, we're talking about this round thing going around here, and one time we're talking about it relative to its central angle, and the other time we're talking about relative to how much ink am I laying down. And can you see, I hope, that they should be in the same ratio. Okay, so when we do this, what we'll do, oh, I didn't figure it out. Okay, we can figure that out. That's divided by 6. Do I have my calculator? I don't have my calculator. But you get the idea. 6x equals 62.8, and that'll give you the length in actual ink and how much it's laid down. Do you see the idea? I hope you do. A sixth of the whole thing, a sixth of the whole thing, a sixth of the central measure, a sixth of the actual length. It's the same fraction, it's the same proportion. And yes, indeed, it is a theorem. I thought you might know. Did you smell that coming? Did you smell that coming? Maggie, did you smell it coming? I bet you knew it was coming. Okay, here we go. Make note of it. This is the same thing I just did. It's stated in general terms, relative to the part of the circle and the whole circle, and the two types of things that we're evaluating. The length, the actual length, a measurement, and then the measure of the angle. Okay, let's work a few problems on this. Let's look here. Okay. Find the exact circumference of a circle with a diameter of 5 inches. Let me see. Circumference equals pi d. Now, why didn't I say 2 pi r? I didn't say 2 pi r because that says d for diameter. So, circumference equals pi times 5, r equals 5 pi. Remember, we'll put the 5 first. Oh, gosh, that was hard. Now, are you supposed to put it into a decimal? No. If you put it into a decimal, it's no longer exact because you recall pi is irrational. Find the exact radius of a circle with the circumference. I want radius, so I'm going to put 2 pi r. Okay. This one's number 6. This one's number 7. There we go. Since this one is using radius, I'm going to use 2 pi r. If you want to use diameter, you can just divide it by 2. Okay, so circumference is 28 pi, and that equals 2 times pi times r. Okay, let's see. Let's divide both sides by 2 pi. You'll recall you can use it just like it's a number because it's a number. So that's going to be 14. Hopefully you see how that works. And you need to be comfortable with working in terms of pi. Lots of times, like look at this. Look how nice and clean that came out. If I had come back here and multiplied by 3.14, even 3.141592653, it would not have been so cute, and it would not probably have turned out to be exactly 14. So you're going to be advantaged in these circumstances for doing that. Okay, let's look at a couple of these. Let's look at this right here. Finding the circumference. Find the circumference of the red circle. Okay, this is tangent. We're going to assume that this is a square. It looks like a square, but we know that's not the best thing. So it's tangent. So we're going to take the radius as 7. Okay. So that'll be circumference equals 14, or 2 times 7 times pi. That was tough. Okay, here we have pi. Here we have the red circle. We know that the radius of the red circle is 5, so the diameter is 10, so the circumference is 10 pi. You're getting the idea, I hope. Let's look here at problem number 11. Give it a go. Let me show you how I'm working it. Oops, there we go. Okay, here's how I worked it. I worked it using the last theorem that we just had. I'll explain a little bit about how that went. Okay. So first I found the circumference because I knew I was going to need it. I have it both in terms of pi and both as a decimal approximation to the 10th. You would always want to know what degree of accuracy is desired. So I've worked it both ways. Here is where I'm going to wind up with the decimal. And truthfully, it's probably better to put 12 pi in here because this is intermediate rounding. No! Okay. Depends on the degree of accuracy that you want, but especially if you're looking at stuff that's close, you would probably want to go ahead and work that as the pi and then estimate it from here. However, for these problems, if it asks for a decimal, this is going to be okay. Notice that this reduces to 1/9, 40 over 360. So in many cases, it'll be easier just to work it as 1/9 instead of having to deal with these larger numbers. Here we've got the same example where it comes down to x equals 4/3 pi, which is accurate, and 4.2 is not accurate. Okay, take a moment and work on do number 12 and number 13. Pause it, and when you're done, unpause it. Here's how I did them. See how you came out. Okay. A little exercise here. Let's look at this. Here we've got a track. Okay. The curves at the ends of the track are shown are 180-degree arcs of a circle. The radius of the arc for the runner on the red path is shown is 36.8 meters. About how far does the runner travel to go once around the track? Let's see what that'll look like. Okay, as it just described, here's the track, and it's composed of half a circle and half a circle that are connected by straight lines. Kind of like the rectangle is the two diameters. In the middle is a rectangle between the halves of the circle. So when you're finding distance, you can just use a whole circle or you can do half here and then add it, but hey, just go ahead and do the whole circle. So you'll have here, notice they've given you the distance between the radii. So can you see that? And if you'll look here, you'll see why it is that the person on the inside track has a much shorter way to go. Go ahead and work these out just for the fun of it. See what the difference is. What's the difference between how far the red runner runs and the blue runner runs? Okay? Okay. And here ended the lesson.